Hi everyone, we're going to talk about theoretical probability. Theoretical probability is just what it sounds like, what should happen in theory. For example, if you have a fair coin with heads and tails, in theory you should get heads half the time and tails half the time. But we know that in real life you may not get exactly half heads, half tails. You flip it a certain number of times and that's fine. But in theory it should be half and half since the odds of heads and tails are both 50%. So that's where the theoretical comes in. What should happen in theory? So for the first one here, we've got a six-sided die. So it helps to write out what we call the sample space first. What are all the options? So our sample space is a list of all those options. So if it's a six-sided die, it's going to be 1, 2, 3, 4, 5, and 6. That's the sample space. Those are all the possibilities when you roll a six-sided die. So if you want to roll a 3, we just count how many 3s we have out of our total. So there's only 1 3 out of 6 total options. So our probability would be 1 out of 6 as a fraction. If it doesn't ask you what type of answer it's looking for, a fraction for a probability is totally fine. You could, of course, convert this to a decimal and a percent, but again, you don't necessarily need to unless it asks you to. For the next one here, we're picking a random card. So for any standard deck, there's 52 cards. 4 different suits and 13 cards of each suit. So getting a 6, well, there's actually 4 6s in the 52 card deck. So our probability would be 4 out of 52 because there's 1 6 for each suit in the 52 cards total. You could, of course, simplify this down to 1 out of 13. Either way, that's saying the probability, and they're just equivalent forms. For the next one here, picking a random card again, so we're out of 52 total. You could write the whole sample space out here, but that'd be a lot of options. So you want to get, in this time, the Jack of Diamonds. There's only 1 Jack of Diamonds out of all 52 cards, so that probability would be 1 out of 52. And we can write probability like this, with a P for probability of what we're talking about. So we can say Jack of Diamonds, like that. A little bit of shorthand with the symbol there. And that's how we can write probability. So for the previous one, we could do probability of 6 like this. And then for the first one, we could do probability of 3. A little bit of shorthand just to kind of denote what the probabilities for each thing is. For the last one here, I've got a spinner with 4 sections, red, blue, green, and yellow, and you can tell they're all evenly sized sections. So I could ask, what's the probability of blue? Well, that would just be 1 out of the 4. Or I could say probability of 2 things, for example, red or green. Well, that would be 2 sections out of the 4. Or I could ask, what's the probability of not blue? That would be everything else, 3 out of 4. Now, probability of blue and probability of not blue have to always add up to 1 because there's no way I could get something different than blue or not blue. Either it is blue and it's in this section or it's not blue and it's every other section. There is no missing option. It has to be blue or not blue, which is why the probability of blue plus the probability of not blue has to equal 1. And it does. 1/4 plus 3/4 obviously equals 4/4, which is 1. So that'll always be true. No matter what we're talking about, the probability of A, whatever the event is, plus the probability of not that thing has to always be 1, which can be useful. Say I ask you to find the probability of not something, but I give you the chance of it happening. Say, for example, the probability of, I don't know, some event C is 3/7. Then you know the probability of not C would be the missing piece to get you to 1. So that would be 1 minus 3/7, which would be 4/7. So it's very useful to know the probability of A plus probability of not A is 1, so you can find the probability pretty easily of it not happening by just subtracting it from 1. And that's how we find theoretical probability, what should happen in theory.